Mahamano Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Head-up display and down display. In this module, we are going to study about the head-up display introduction, head-up display component, head-down display introduction, and head-down display component. Head-up display aircraft. HUD head-up display is a means of presenting information to the pilot in the line of their external forward vision, which projects key flight instrument data onto a small see-through screen positioned just in front of the pilot line of sight, looking ahead out of the aircraft. HUD system components: a computer to receive aircraft data and generate display symbology, an overhead unit to mount the cathode ray tube CRT, which projects the assembled image onto the transparent display screen in front of the pilot. The transparent display screen, called as combiner, which is holographic optical element made of glass or plastic that reflects the projected image towards the pilot's eyes without interfering the passage of ambient light. A control panel allows selection for the pilots of various display options and to enter data not received and integrated by the computer from aircraft sensors. An annunciator panel to provide HUD status and warning information. Refer the image below. HUD content. An early HUD typically provided a combination of situational and guidance data. Most of this was taken from the PFD, H-down display, HDD, and equivalent analog instrument. Since the early days of electronic flight instrument system, the size of HDD EFIS screens had increased quite considerably so that much more information can be displayed on the primary flight display PFD and therefore also on the corresponding HUD. The original airspeed, altitude, localizer, and glide slope were quickly joined by the key derivative information on the energy status of the aircraft, a flight path trend vector FPV. This was also followed by a flight path marker, an airspeed trend vector, an angle of attack indication, and a notional depiction of runways. Some systems also have some of all the landing flare cues, tail strike warning, unusual attitude, wind shear detection and recovery guidance, stall margin indication, and airborne collision avoidance system ACAS alerts and advisories. For the landing or rejected takeoff in low visibility, runway distance remaining and ground deceleration display can be a crucial aid in preventing runway exertion. One deceleration display currently available gives back braking performance as 1, 2, 3 or max, which corresponds directly to auto brake settings, so that for the landing roll a clear display of any unexpected runway surface contaminant status is provided. Potential difficulties with HUDs. Two key problems have been routinely identified with HUD use, which is important to address during a specific flight crew training necessary for its use. Attention capture, also known as tunneling, in which pilots can become focused on the HUD display to exclusion of adequate reference to the events or information outside the aircraft. Critical information in the outside aircraft scene is obscured by display imagery, and design solution for this is to keep the number of symbols low to avoid enough clutter. Reducing the clutter can also help with the attention capture. Lower approach minima. HUD was used early on the alternative manual flying means of conducting instrument landing system ILS CAT 3A auto land in low visibility, mainly because of the lower maintenance cost and better reliability than the traditional auto land system. It also enabled these low visibility approaches to be made to runway without the usual ground equipment and redundancy needed to support ILS approaches in these conditions. Federal Aviation Administration FAA certification is also now selectively given to EVS HUD system to use lower minima than published for both straight-in approach using both CAT-1 instrument landing system ILS and the non-precision approach flown using the procedure for continuous descent final approach CDFA. Both are able to use a DH of 100 feet above reference threshold elevation before the standard acquisition of visual reference is required. Have a look at this image. Head-down display HDD, a display inside the cockpit, usually a radar scope or a CRT raster with the symbology and TV overlay. It normally is placed below the alongside instrument panel. These displays located in the cockpit such that the pilot has to look down at the instrument panel to observe them. They are distinguished from the instrument in that they show, in part or entirely, a computer-generated image. The information may be a replication of traditional instruments showing attitude, speed, altitude, or navigation data, for example. Other formats might show engine data or store management. More sophisticated systems display a map with superimposed steering cues and waypoints. Radar, FLIR, and low-light TV pictures may also be presented with overlaid data. Originally, HDD used monochrome cathode ray tube, and later color CRT were used, but modern HDD will use LCD panel with significant advantage for installation depth. This was all about the HUD and HDD. Thank you.